It's time for the real definition of limit. It's 2.7.
Okay.
As soon as you know that, you should ask me whatever questions you possibly have about anything up until this point. And work it all out. Make sure everything's sharp before.
So the exam is 3 hours, right?
It will not take you 3 hours, I can guarantee you that. You have any questions? But you'll have plenty of time. So that you'll have more time than you need.
So 2 hours, right?
You have more time than you need.
Okay.
I assure you. You have any questions at all?
More time
Time will not keep you from doing well in this test. That I can guarantee you.
So it's more time than a regular exam on a regular semester. For a month.
You'll have all the time you need.
Okay.
Is that pencil sharpener anywhere nearby? That I don't know.
Use lead
I
pencils.
do not have any pencils. I have one single pen.
Always use lead pencils.
For your lead exam.
Come on, guys. Bookstore. What?
So this is the one part of the class will involve proofs on your guys' part.
Oh my god, this.
I'm sorry. Thank you.
Nobody else? Alright.
That is the pile of symbols we used before to describe that a function is heading towards a certain value L when x is heading towards a certain value A. Right? So the limit of f of x as x approaches A is L. L is a finite quantity in this case right now. So this has a actual mathematical definition, and that is if I want to write it in. Sorry, I won't use this. I'll just write it in. If for all epsilon greater than 0, there exists a delta greater than 0, such that
I'm sorry, what is that thing? If for all what?
epsilon. What's epsilon?
Yeah, what is that?
Yeah, what's
It
that?
is a number greater than 0. Any number greater than 0. And usually epsilon is very small. Epsilon is the Greek letter E, basically. It stands for error, for the most part. That's the way to think about it. Let me just finish up the definition, and I'll show you what I mean by error in 1 second. So, for all epsilon greater than 0, there exists a delta, another quantity, greater than 0. Again, probably pretty small. Doesn't have to be, it usually is in these contexts. Such that if goodness sakes, I'm so old. Oh, jeez, says that if the distance between x and A is smaller than that delta we just talked about, that's going to force the distance between the function and our limit to be less than that epsilon. That is the actual definition of a limit. It's Cauchy's definition, if I'm not mistaken. Mathematicians work very hard to figure out how to define limit in this way so that it would be what it's supposed to be for all calculus. All right, so what is this trying to say? It's trying to say, again, epsilon is any number greater than 0, but it usually means very small numbers. So what it's trying to say is, no matter how small, you should pick epsilon to be, okay? 0.00001, no matter how small you want it to be, okay? Any real number, no matter how tiny, and you slap it right here, right? It's going to force the function to be that close to L, right? Which is what it's heading towards, right? So you can, if you can make this quantity as small as you like, and I can find a number here that makes that happen, then it is the actual limit. Okay?
What's
Okay.
the difference between the two symbols?
The delta and the epsilon?
Yeah.
The fact that they can't be the same. They could be the same in certain contexts.
so
They're not
just-
necessarily the same.
Okay.
We'll take an example. Let's take a linear function. Try to explain what I'm saying. X plus 1. And we'll pick over here, I don't know, 2 or something. So what's the height? 3? Okay. We'll make it a whole. We'll make it a whole. I'll just leave it how it is. 3, 2, 1, 1. This is 2, 3. X equals. Okay. Limit of f of x as x approaches 2. What is the answer? 3. The answer is 3. Continuous function, right? 3. Its own function value. Okay. So what this is trying to say is, Rosales, pick a number for epsilon.
Any number?
Yeah, any number.
Like
1? That's reasonable. That's totally reasonable. Okay.
Yeah.
Epsilon is how far away your function is from the supposed limit. How far away your function is from the supposed limit.
This is the limit is 2. This is the function. The difference between the function and the limit is e.
Minus, what do we suppose the limit is? We suppose the limit is 3, correct? That's what we're supposing. And Rosales is giving us a value of 1. So now, this has to work for every epsilon, but I'm giving an example of a particular epsilon right now. Particularly, we've chosen the number 1. So now, Lou, I want you to find a delta that will force this to happen. Can you find, right? Given that epsilon equals 1, can you find, a lot of the problems in the textbook and probably online are based around this particular setup right now. Not formal proofs, but just given a particular epsilon, can you find a certain delta? Okay, so this is important. It's not just leading up to the proof we're going to do, it's also part of the homework that we're going to do. Okay? Can you find a delta no, not 100%. That makes that happen? Can you find a delta that makes that happen? What's that? This, right? That the distance between your function and 3 should be at most
Less than 1.
should be less than 1. Okay, I can't say most than 1. Should be less than 1. Should be strictly less than 1.
Wait, what?
Can you find a number that bounds the distance between x and a, which our a is the number 2, x minus 2 less than delta. Can you find a delta that this holds for that makes this happen?
Just need a number, right?
Yeah, just give me a number.
Since a is 2, it could be anything below 3. I mean, between 2 and 3, so anywhere from 2.1 to 2.9. So it can't be greater than 1. I mean, yeah, it can't be greater than 1 and less than 0, right?
Just give me a number for delta.
Is it 2.3?
Right now we're saying this.
Where's the purple? Where's the purple?